All right, so this is the Grey Kangaroo from 2015. It was the paper that half of the class did last week, just to see some answers then. Let's go through it. So we just need to look at these as we go along. The umbrella here can read A, N, G, but you need to look at this very closely, right? From A to N, the flick on the N here goes from the bottom to the top, reading from the A side. But if we read across the A side here, it goes from the top to the bottom. So this one doesn't quite work. O to RO just never appears as a sequence. That goes away. GAR, well, the R is backwards, clearly, but the G isn't, so that doesn't make any sense. Here we've got NGA, which I don't think appears as a sequence. Doesn't look like it. And then again, I mean, if you're going to test the answers, I'm going to say this a couple of times in papers, but if you're going to test the answers, test from the other end, test from the E end, because clearly OOK appears from above here. And so it's going to be E. Which is closest to this? Well, this is close to 2 times 500, which is 1,000. So pretty easy. Smaller side is 10, so that means this is 10 and this is 10, I guess. But of course, that means this is 10 as well and this is 10 as well, which makes this whole thing 20. And read the question carefully. What's the length of the longer side of the large rectangle? So we're looking for this whole thing here. Well, if the long bit is 20 there, that makes 10 plus 20 plus 10 to make 40 in total. Just read the question carefully. Which of the following is not an integer? Well, anything divided by 1 is itself, so that's fine. This is even, so that's an integer 2. These sum to 1, 2, 3, 4, 5, 6, so this is divisible by 3, so that goes away. And this ends in a 5, so that is also an integer, which means this must be the right answer without even calculating it at all. That triangle has perimeter 6 plus 10 plus 11, which is 27. Equilateral triangles have all sides the same length. 27 divided by 3 gives you 9. 5 meters per second. Now, the question is about 5 seconds. The first thing I did was just time this up to make 25 meters in 5 seconds. And then I can just do 25 meters divided by 125 centimeters. Now, 125 centimeters is 1.25 meters. So I'm actually doing this division here. Double both of them because you're allowed to do that in division, and then double both of them again because you're allowed to do that in division. And the answer is clearly 20. In a class, no two boys are born the same day of the week. So the question is about maximizing the number of kids in the class, like how many at most there are. So if no two boys are born the same day of the week, at most there are 7 boys because they could all just be born on different days. You could have 5 boys born on different days, but at most there are 7. The minute you have an 8th boy, he has to be born on the same day as another one that you've already got. It's called the pigeonhole principle, just in case you want to look it up. Same thing with the girls, but of course there's about months, so that's 12 of them, and therefore there's 19 of them. If it's definitely true that, like, because if there are only 5 boys, then you could add a boy to the class and they might miss all the other boys' days. But sorry, that should say girls, shouldn't it? Whatever, max 12 girls, and then 19 there. Okay, cool. So this question here, I decided to just say that this length up here was 2 because each side is 1, so this whole height is 2. And from here to the corner here of the shape, we've got 1.5, so that's 1.5. Now, if you work out the whole area of the triangle, including this blank bit, that's just a half times 2 times 1.5. A half times 2 obviously cancels, so that's just 1.5. And now all I need to do is take away this blank white rectangle, which is width a half, because this square goes across half of this square, and then obviously height 1. So 1 times a half is a half, I guess, and you just take that away from 1.5 to get 1 in total. So here, we want to minimize the number of pluses. So the first thing you can think when you look at this is, well, let's just make all of the ones that precede 0 minuses, because it doesn't matter whether those are pluses or minuses, but we're trying to minimize the pluses, therefore maximizing the minuses. So let's make all of those minuses. And then we can just get rid of them because we don't need them. Now we look at this and go, okay, well, again, if you're minimizing the pluses, your idea should be to add as much as possible in one go. So add the 5s, right? Because adding one lot of 5 is more effective than adding a 2 or a 1 or both even. So let's just add in 2 5s, because adding 1 5 clearly isn't going to be good enough, and taking away all the other stuff, that's clearly not going to make 0. So let's just add in 2 of them and see if all the other stuff can just be minuses, and it works perfectly. And again, 1 clearly won't work, so the answer must be 2. 15 litres of water fell per square metre. Now, first thing to say is that a litre is 1,000 centimetres cubed. So 15 litres is obviously 15,000. Now, a square metre is, well, 1 metre is 100 centimetres. So if you square both sides, you get 1 metre squared is 100, is 10,000 centimetres squared, with 4 zeros, I guess, just squaring both sides. So we've got this amount of water falling per this. So let's just do this divided by this to find out how much has risen. Of course, all the zeros cancel, you just get 1.5. So that will be our answer. Okay, question 11. We have 10 branches. and each branch is either this or this. So let's call these branches A's and these ones B's. The total number of, what are we looking for? Total number of leaves will be 5 times the number of these types plus 2 times the number of these types, except the 2 types have got to add up to make 10 because we know it has 10 branches. Which could be the following number. Well, this is a bit of an advanced trick, I guess, but it gets it done really quickly. Take away A or B from both sides here, it doesn't really matter, and then put it back over here. Well, okay, I guess times it by 5 first, so we can put it back in straight away. And we get 50 minus 5b plus 2b, which is this. Now, that's a simple expression for the number of total leaves. Now, if we were trying to make the total leaves 45, we would have 50 minus 3 times something is 45, but that doesn't work unless b is a whole number. If b is a whole number, right? 3 times something can't be 5. So we can't do 45. We also can't do 39 because then we would need 3b to be 11 based on this. That goes away. And in fact, all of them go away. And you end up with E as your only answer. And the mean score of the students who took maths test was 6. At this point, we just make up that the number of students is 10, because that's a nice number to work with if you're doing percentages. 60% passed, that means 6 passed. It also means that if there are 10 students, 10 times the mean of 6 is 60 total marks across the entire class. 6 passes, 6 times 8, because their mean was 8, is 48. That means 12 marks for all the people who failed in all together. There are, of course, 4 failures based on this, and of course 12 divided by 4 gives you 3 as their average. We have the area of this square, like if you make this square here, the area of this square is 1 more than the pentagon that's made by folding this over, which means this little triangle has area 1, which means this little triangle has area 1. And then you can just draw a line here and here and say that, well, all of those areas are just 2, so the total area of the square is 8, clearly. It's tempting to do more complicated things, but that's definitely the easiest way of doing that. Rachel added the lengths of the 3 sides of a rectangle at 44. Now, you could say the 4 sides of a rectangle are A, B, C, and D, but remember it's a rectangle, so it's got to be A, B, and B, because that's how rectangles work. So let's just say, and then the only way to add 3 sides is either 2 A's and a B, like you take these 2 and this one, or 2 B's and an A, right? That's the only 2 ways of doing it, and you get those 2 results. This is just a simultaneous equation. I think I just doubled this one and took it away, and then found A, and then found B, and then you can work out the total perimeter by doing that. Good. Question 15. So if this triangle already has a blue side, well, let's look at this side here. This triangle already has a blue, and this one has a green, which means this can't be blue because then it matches that one, and this can't be green because it matches that one. So that must be red, which means this is green, but that doesn't really matter. Then we keep going. This one must be blue because it's already got a green and a red side. And then we work from the other end. This must be red for the same reason we looked at over here, which means this must be green. And then you look at this side and you think, well, okay, it can't be, this side here can't be blue because this side is blue. So this triangle will have 2 blues, but it also can't be green because this side is green. So this triangle will have 2 greens. So this must be red here, which makes X must be green. And there's no other choices available. 5 of our students all answered how many of them had done homework. Daniel said none had done. Now, the key here is that the people who had done the homework, the people who hadn't done the homework were not telling the truth, but the people who had were. So Daniel said that none of them had done it. So if he's telling the truth, that means he hasn't done the homework because he said no one has. But that's a contradiction, because if he hasn't done the homework, he's not telling the truth. So Daniel must be lying, and he mustn't have done the homework. Then we get to Ellen, and you're like, okay, well, Ellen could be telling the truth as long as she was the only one who did the homework, and everyone else didn't, right? So Ellen could be the only one who did it, and then her statement is fine, which would make Clara's statement a lie, which is fine, because on that basis, Ellen is still true. She's the only one who did it. It would make Zara's a lie, and it would make Marcus's a lie. So that's pretty consistent. So therefore, Ellen is the only one who did it and is the only one who's telling the truth. Good. 17. 17 is a really fun question because it seems really confusing, but then you can get it done straight away just by busting out some algebra. I thought the fastest way might be to test some numbers out from the answers, but it doesn't really work very well. Call this region A and B and C and D. And you can actually get this done very quickly because notice how many regions are connected to other regions, right? So -4 is connected to A, B, C, and D. So those 4 things added up must be -4. But this 2 is connected to all of them except for -4. It's A, B, C, and D, and question mark. So we can write down those 2 statements, and then we can just do one take away the other. And you end up with question mark is 6, pretty much straight away. Good. Question 18 then. So 5 integers, not necessarily different, written on cards. and we get these totals here. Now, this is where we're going to test some answers. Let's pretend that the largest integer on the card is 18. Sorry, is 35. Of course, it's got to add with something to make 83, but 83 minus 35 is 48, and that's a contradiction. That means that the largest number on any card is not 35, so therefore we'll get rid of that one. 42 is slightly more difficult to get rid of, but we can get rid of it, because if you do 83 minus 42, you get 41. So that means another card must be 41, so that it adds to make 83. But then you notice that these two cards are different by 1, which means whatever you call the last card, you could call it 29, just because 41, I think, 29 and 42 make 70, or 41 and 29 make 70, I think I was doing. But the problem here is that because these two cards are different by 1, you'd expect a sum to be different by 1 when you did the other card plus the 29. So this just doesn't work at all. Skipping to 82, that's the next easiest to get rid of, because if a card is, of course, 82, that just means all the other cards have to be 1 to try and make an 83, and the whole thing just breaks down straight away. And then I was trying to get rid of 48, but it turned out I found a consistent solution for 48. Of course, you do 83 minus 48 to get 35, that's your second card. And this seems good, because notice how they have a difference of 13. And this difference in sum here is 13 and here. So this seems like it's going to go pretty well. If you make C 35 as well, not only to make this also add to 83, but to make these two add to 70, then you can make another one 35 and your last one 22, just to try and get a 57 out of this, and it's nice and consistent, and 48 will be the one that works. This is a pretty tough question. Draw some extra lines from the corners out to the points that you've got here and here. So here first, I guess. Now, because of symmetry with this triangle, these two triangles are the same, right? Because they have the same length here, they have the same length across here, and it's just all symmetrical. So this is 4, which means this area here is 5, because it's the whole thing there is 9, so 9 minus 4 is 5. You can do the same thing over here with symmetry around this 2 to get a 3 here, and then you can actually keep going with this, draw some lines to this one here, and you can use the same kind of logic, again, by symmetry. If this one over here is 5, this one here must be 5, and likewise there, this must be 3. And now, if you use the total area of 30, you can work out that these two must be 1 and 1. Okay, so now which one of those lengths is biggest then? Well, we can rule out A, because A must be smaller than E. Again, by symmetry, this area is just bigger than this one. And we can also rule out B, because it's smaller than D. C seems incredibly unlikely with only an area of 1 here. So I'm basically just thinking it's either D or E. And a very hand-wavy answer to this would be that I know that this length here is shorter than this length here. Because, like, if you imagine getting this length here and, like, moving it up this line, like turning it, making the angle bigger as it moves up this line, the length gets shorter and shorter the closer to the middle it gets. So this length is shorter than this length. And also this length is shorter than this length. So for this area, this triangle to be having a bigger area than E, I think D has got to be a bigger length than E, because its other two sides are smaller than the other triangle, so it's kind of got to compensate for it. So I think D, hand-wavy solution, but D just looks like it's going to have to be the bigger one there. So we'll select it, and we'll move on because we're tight on time. In a mob of kangaroos, the two lightest, 25 the totals. Let's call the total T, and the two lightest, which I'll just call A and B, as 0.25 times T, because of course that's the decimal for 25%. The three heaviest, which I'll call C, D, and E, weigh 60% of the total weight. How many kangaroos are there? Well, if we add these two results together, we get 85% of the total weight. So somewhere, some other kangaroos weigh 15% of the total weight. Now let's think this through clearly, because if there are two kangaroos in this extra pile, and they together weigh 15% of the total, that's a contradiction to the first line, because A and B were described as the two lightest kangaroos, adding to make 25% of the total. So if there are two kangaroos here making this, then they would be the two lightest, not these. So there can't be two here. There obviously can't be 3 or 4 either. But there also can't be one of them. Sorry, there can be one of them. That's the only way to do it. One of them is worth 15% of the total. And so therefore there are 5 plus the extra 6 for 6 in total. There can't be 0, of course, of them, because you've got to get the weight from somewhere. So the answer must be 6, and because there's no answer of 5. Question 21 is just a terrible, terrible question. But it's also great because it sort of teaches you about which questions to completely ignore in the challenge, because you'll waste way too much time doing them when you could be doing actual questions that have actual answers that you could maybe find. So this question is gross, right? Each side of the square is 1, so there's, sorry, the cube. So there's 12, the length 12 in total, right? Because there are 12 edges, I should say. So we need these wire pieces to add up to 12. Now they need to add up to exactly 12 because there's no overlaps. One way to do it would be 5 and 7, and you could just draw some 5 and some 7 coming around here, but it just doesn't work. Like there's way too many like dead ends to have any hope of this working. I think if you try it, just draw a 5 around, you'll pretty much immediately see that this isn't going to work. 5, 6, and 1 has more chance because this 1 can cover one of the dead ends. So if I show you what I mean, you can do 5 like this maybe, and then you can use a 6, and one of the dead ends can be covered. But I just couldn't find a way to do a 6 without leaving 2 dead ends. So, okay, I moved on to 3 pieces, to 4 pieces maybe instead. What am I doing here? So I tried another thing, right? So here's another way of doing 5 and 6, but you still end up with 2 dead ends. Like I just couldn't find a way of doing it. So, but what if you tried 4, 6, and 2 instead? Like because I was ending up with 2 dead ends. So what if I made a wire piece of 2? But I still couldn't find it, right? And like I said, I was wasting an enormous amount of time trying to do this, and it just wasn't working at all. You move on to 4. Again, working way up. You kind of have to work your way up like this because even if you found a solution for 5 working from this side, you couldn't then just say the answer was 5 because there might be a solution for 4. This is the thing to try that I tried for 4 because I figured, there are other configurations that make 12, like including a 6 and a 7. In fact, no, I don't think you can use a 7, but you can use a 6. This seems more effective because the shorter pieces of wire are better because they fill in the gaps easier. Like them, it's just somehow I don't know how to describe it, but it's just easier to use shorter pieces of wire than one big long one. And eventually you can find this solution if you do the one that we've got here. You've got a 4 in the purple, a 5 in the green, and then these 2 can be filled out with the 2, and then there's the 1 there. So it is possible in 4. Um, yeah, the mark scheme also doesn't provide any more information to you other than, oh, just try it. You can do it in 4, and that's basically their entire solution. So I did the right thing. It's just a horrendous question. Anyway, we draw a trapezium PQRS. We try and draw it loosely to look a bit like the information they've given us. RSP is 120, and then PS and SR, which is this one and this one, are a third of PQ. So let's just call them lengths 1, 1, and 3, just because making up numbers is always good. This angle over here is 60, and we're looking for this angle over here. 60, of course, because it's co-interior with this one. These two sides are parallel. And we're looking for this angle over here. We need to do some trig for this, or at least it's by far the easiest way to do it. So let's just draw a line here and then say that if we want to know both this distance and this distance, which I do, I'll start with some cos because this is adjacent over hypotenuse. Cos of 60 must be this divided by this, but this divided by 1 is just itself. So this is just cos 60, which I know is equal to a half. Again, it is trig. You do just need to know an exact value. There are other ways to do this question, but just knowing your exact values is really helpful. This is just sine of theta by the same logic, which is sine of 60 is root 3 over 2. You can transfer that over there, and then this length here is going to be 3 minus a half minus 1, because that's this distance here, which is 1.5, or 3 over 2. And then, of course, this is opposite over adjacent, so tan of x is this divided by this. The 2's cancel to get root 3 over 3, which might be more familiar if you kind of say this is 3 to the half divided by 3, which is, I guess, 1 over 3. I mean, this is root 3 times root 3, I guess, so you can cancel the root 3s, you get it like this, but it's more recognizable, I guess, that 30 must be the answer because tan of 30 is that known value. If you don't know exact values, you're kind of stuffed on that question, I guess. There are other ways of doing it, but I don't really want to do them because knowing your exact values is just the much easier way. Anyway, we have, when you're doing questions like this, you just need to draw them up as you go along. So like we start with a point, there must be 2 away from somewhere. So we say it's distance 2. Now, this distance 5 is interesting because you could say, well, okay, the original point is 5 away from another point. But that doesn't work because that makes this distance 3, and you don't have a distance of 3 here. These are in order, so k must be between 9 and 15. So this doesn't work. But you also can't make the 5 coming from this second one because that makes a distance of 7 here, which k also can't be because, like I said, it's between 9 and 15. So neither of those work. So that 5 must be the distance between 2 other points in the picture, not the first, not anything to do with the first 2 that you're drawing here. But this 6 looks more hopeful because if I put the 6 away from the third and the second point, then that makes that total distance 8, which is also a figure that I have. And then you can maybe go to the other end and go, well, okay, the 22 must represent the distance between the first and the last point, which is 22, which means, of course, because of this 2, this 20 represents the distance between the second point and the last point. So, okay, but then going further, because this distance is 8, the distance between these 2 must be 14, right? And you don't have a 14 in the list, but k is nicely in that space, so k must be the 14. 24, 2015 divided by every number up to 1,000. What's the largest remainder? Now, the first thing to say about remainders, of course, is that they cannot be bigger than the number you're dividing by. So, for example, if you divide anything by 8, the remainder can't be 9, right? If you divide by 8, the remainder is between 1 and 7. Because, of course, if the remainder was like 11, it just goes into 8 another time. So the answer cannot be 1,007 because you can't divide by something less than 1,007 and get a remainder of 1,007. It could be 671. Now, if it were 671, you could possibly be dividing by 672, right? Because 671 would be the last remainder possible. So it's possible you're dividing by this. If you just do 3 times 672, you very conveniently find that it's 1 more than 2015. So 671 is definitely a remainder that's possible to get. So we could circle it and move on. Or we could try and justify very quickly why we can't be bigger than that. And the justification is very quick, which is that, well, okay, what happens if you just divide by something? The only way to get a remainder bigger than 671, as I've already said, is to divide by something bigger than 672. Right? So let's divide by something bigger than 672, like 700. But then when you do 700 times 2, you get this, and that's only 615 away from where you need to be. So that's now the maximum remainder is now dropping because you're essentially getting closer, because the numbers are bigger, to the answer itself. So 671 is definitely the biggest thing we're going to find here. And the last question, every positive integer should be coloured, red or green, and then they add up. Now, the obvious thing to do here is say, well, evens red, odds green, but that doesn't work because odds plus odds make evens. So, sorry, it should be green, shouldn't it? Not blue, but who cares? So that doesn't work at all. One way to make it work, so let's just try and draw it out. Make red the 1 red, then you make the 2 green. Now, let's think carefully about the 3. If you make the 3 red, then 1 plus 3 makes 4, and the 4 has to be red as well. But then 1 plus 4 is 5, and the 5 has to be red as well. And so on and so on and so on until, I just randomly put 500 here. Everything's going to have to be red, and 2 is the only green one. But that's fine. Like, you just have red numbers for infinity. That's one way of doing it. But you can also do the same but swap the colors. If you started green and made the 2 red, then all the others could be green. Likewise, if you start with a red 1, but then also make the 2 red, no, well, now the 3 has to be red because 1 plus 2 is 3, and then the 4 has to be red because 1 plus 3 is 4, and so on. And they're just all red. And then you could do the same as swap colors. So there are definitely 4 ways of doing this. What if we made not... So I started with a red 1, and then I made the 2 green and then the 2 red. Now, I did have a choice up here, which is what if I tried to make the 3 green as well? Like, is there a way to make this work? Well, 2 plus 3 is 5, so the 5 has to be green. Now, that means the 4 cannot be red, because then 1 plus 4 makes 5, so the 4 has to be green as well. But then, 2 plus 4 is 6, the 6 has to be green. But then 3 plus 4 is 7, so the 7 has to be green. And everything is going to have to be green. Basically, you're not ever going to have another red number here. And the moment you do have another red number, they'd all have to be red anyway. But then you'd have sums that were green that would have to be green. So you're just forced to make everything else green here. And then, of course, you can do the same and change the colors. And I think that's all you can do. So the answer will be 6 of them. Again, justifiably the only thing you can do, because you try one number to start with and make it a color, then we've done all the things we can do with 2. And then if you try and make the next one the same as the 2, you get this case, and if you make it different, you get this case. So I think we've exhausted all the cases, and the answer is definitely D. Anyway, thanks for watching. I hope that helped.